By the way, this also happens in time. Have you ever watched a video where an airplane propeller is starting to go, and then all of a sudden you start to kind of see it spinning backwards, and then you see it spinning forwards? Okay, airplane propellers don't spin backwards. They only go forwards. So what's going on there? Oh, and by the way, I hope you know that if you were actually standing out on the tarmac watching the airplane, you wouldn't see this phenomena. The reason you're seeing this phenomena is that this was recorded on either video or film that was taking a picture every so often. And that's what's displayed here. Imagine we have this wheel that's turning this amount each time. So if you track the dot, you can see that the thing is turning almost 90 degrees at every rotation. But if that dot wasn't there, you would actually see this thing going backwards just a little bit because of the fact that you couldn't tell which one of those cross patterns was which, and so you would see it rotating backwards, okay? And that's aliasing in the temporal domain. We'll talk about that in a minute. In the spatial domain, and essentially the thing is moving too fast for how often you're sampling at time for you to actually be able to tell what's going on. The high frequency and the low frequency can't be distinguished. To show you a simple example in an artificial image, we'll see some natural ones later. Here we have a rendering, and as this checkerboard gets further away from you in the distance, right, it's supposed to start getting thinner and thinner and closer, and you'll notice that somewhere right around here, it starts to break up. It's not looking like a checkerboard look. In fact, look at this nonsense, right? It's like low frequency all over again. What's going on? Well, we can look at that in MATLAB, all right? Suppose we have this input signal. Okay, this is like that chirp that I was showing you before. Well, we can plot this as an image in MATLAB, and that would look like this. Okay, so here I'm just doing x from 0 to 5 by 0.05, and I did this image of sine of 2 to the x times x, all right? And what you're seeing is, so it starts off a slow frequency, and then it's getting higher and higher, and eventually you start to see stuff that looks like that. So what's going on there? Well, that's aliasing. There are not enough pixels in the plot for you to be able to see what's going on. And that's illustrated down here where we have a small number of samples, a not dense enough sampling in order to recover those frequencies.